Okay, cool. Today the talk is just going to be on end-to-end testing with Terraform. Terraform is a tool from HashiCorp. You simply use it to spin up servers, or in this case, basically something called infrastructure. It's basically like a very big word for a personalized setup of your services. So at the moment, my name is Bakare Emmanuel. People call me Backman. It's kind of like a very small nick. I like to say I'm an express plumber because what I pretty much do is fix pipelines and other stuff. Sometimes I also break stuff. Kind of like falling over that kind of thing. Also, a failure comedian in real life. I might go there, but I might not really make it. So just easing out on the dev work for now. And then you can always check out my website and follow me on Twitter. I post some interesting stuff. You might like it. So it's basically testing, right? Testing is pretty straightforward. Until you don't really do it, they're like, I can pretty much leave it out for now. No issues with testing. Then you write a couple tests one day because you really have to. It's not like you really need to. Some people just feel like, at some point you have to just show that. Yeah, it works. Then you remove some because they don't work. Pretty much like I think we've all done this before. Where we set up a service, then we disable the test, push it to production. Then we were like, testing was actually pretty easy. Like 1 was equal to 1. We didn't really check anything. All the values were fine. You keep on writing more code, no tests. Keeps working until one day it doesn't. So the thing about tests is that writing code, sometimes it works, then things change. Some services get pulled out. Some APIs change on AWS or GCP or Azure, they'll get deprecated. Some new features get added and interfere with stuff. Somebody pushes the spoil button on your server. Different things like that. You never know who's doing what. Then it's no longer simple, right? You get to this point where that 1 is not equal to 1 because now that 1 is a string, and sadly, your infrastructure doesn't allow that. Infrastructure testing is pretty much like this. Things change a lot. And when they do change, you can't really set it up the way you just write like your normal code. Like you actually need to run everything live. You can't test code by mocking. You have to literally spin up your infrastructure to mock it in reality. So even if you were to find a way to hack it, you just do some light testing, it doesn't always work because you've got like multiple environments. And these multiple environments have different services working on there. Some have, some different configuration. And then, somebody might be deploying dev to prod. Somebody might be deploying staging on dev, different configurations, and you don't even know whether it's working or not. That's why testing is really important, right? The testing parameter pretty much goes from unit testing to integration testing to end-to-end testing. Although pretty much people don't test infrastructure. So, that's what I'm actually going to start off by, getting off with this. So, HashiCorp has quite some tools. I'm pretty much just trimming them down to Terraform and Packer. So I'm going to be doing like a very short demo. I'll be spinning up the entire infrastructure with Terraform. So Terraform is they call it infrastructure as code. Simply, it just helps you not have to, go to the AWS console and start clicking on buttons to create the infrastructure. You pretty much write it the same way you write code. It has all the functions and different things that you actually use to spin everything up. So to actually then, do everything, I'm using AWS because, Terraform and Packer help you build things, but then you need to host it somewhere. So I'm using AWS and then Docker to run like some very small application that we can push on the VM that we'll be creating. Then with Terratest, which runs on Go. So I pretty much gave the Go logo the HashiCorp insignia. It pretty much looks cool. I think it's leeching on it, so moving around. But the main idea is that all these tools pretty much form together and they work very, very nicely together. You could change AWS with GCP. You could change it with whichever cloud platform you like. Terratest supports multiple clouds, supports multiple services, it supports even testing Docker, supports testing Packer. So every single tool that we have listed here can actually be tested using Terratest. So what is Terratest? Because I've been talking quite a lot about it. So it's basically a testing library. So similar to how you write infrastructure code, you need to actually run it to test. So Terratest helps you spin everything up, check whether it's working, then it basically takes it down. It doesn't really do anything more than that. But the good part about Terratest is that it's already been pre-configured with different modules that, you know, the modules are basically like, okay, fine, if you want to test Terraform, there's a part of Terratest that can handle Terraform code. There's a part of Terratest that can handle Packer code. There's a part of Terratest that can handle Docker code and all of that kind of stuff. So you never really have to leave that environment. You can pretty much use the modules to test everything. And it makes sure that it works because you can also extend it too. So right now, I'm just going to showcase like a very, very small demo. The repo is actually here on github.com/tma/HashiTalks Terratest. Should have made this link a lot shorter, but this might work. So I'm going to change over. I'm going to change over which screen I'm sharing so that to my IDE, then just basically showcase how Terratest works. So whenever you are using Terratest, you first of all need to write some Terraform code, which I'm going to show you guys. So in this case right now, I have a couple, they call them modules. So remember when I was saying you can test your modules. So modules are just like, it's basically like a folder with Terraform code inside. Like that's simply what a module is. The only difference is that now the variables that you actually pass into it, you can basically just have it stored in one place. So this is me using a module. This instance, this instance module is from here, from this main.tf. So main.tf is where we most times keep our resources and everything. But the main idea here is that because of the way I've written it, this is basically a module, right? This is going to deploy like an AWS instance. Pretty much basic stuff, you create it. For those of us who actually haven't used Terraform before, it's pretty much very straightforward. All that I'm doing is that this is basically the operating system I'm using. This is the instance type. All of this is found in here, like a variable. So you just put it in there and then, you can define it. So in this case, you can see that this is the instance type that I'm basically pushing on here. Is basically a 2 to the micro, like a very, very small VM, like 1 gig of RAM, that kind of thing. So moving on, like this is all the code I will basically write. Like it doesn't really have to do anything. It just has to run in this same manner. And then from there, we can now check whether everything is good. So let me actually then run like a very quick demo. I'm actually going to do a demo with Bakare. So this is basically Bakare. Bakare basically helps you test. Bakare helps you test your build. So like say I have a custom image that I want to make on Terraform. Rather, I want to make so that I can run it in a VM, for example. You can use Bakare to do that. So the main idea of this talk is that when you're basically doing it, you basically have Bakare build an AMI, basically a very big word for like the operating system and all the files that should be inside. Then we basically use that to run a VM. Then we can now run our application in a container with Docker. Very, very straightforward. So normally when you're running with Bakare, you can use Bakare validate to just quickly test everything. Rather, Bakare, so Bakare validate, then you basically pass in the name of the file. So I'm going to do Bakare validate builder.json. So we'll do Bakare validate builder.json. That should actually be there. Bakare. Yeah, so that should actually be good. Oh yeah, sorry, I'm actually in the test folder. So I'm going to cd into the modules folder where Bakare is, then I can then run Bakare validate builder.json. So now I can run Bakare validate builder.json. And this works fine, right? This is like a small version of testing, right? You test whether it's valid, then from there you can now run the actual test that verifies that everything works fine. So to do that, I'm basically going to go to a test that I've written. This is where Terratest comes in. So in this case right now, you notice that I have a couple stuff imported. For those who might be looking on, this is Go. It's very, very straightforward. I'm just importing Terratest. I've downloaded the libraries before. To download it, you can check out the documentation on Terratest. It's actually quite explanatory on where you can actually find this. So basically, I download the module for Terratest. I'm using the modules from Terratest. I'm using the one for AWS and one for Bakare because since I'm building an AWS image, I'm going to push in it to Packer. So all I'll do right now is just to test this, right? Because yeah, like the validation went fine, but like, is it actually going to build? So in this case right now, I'm going to basically run this. It takes quite a while to run. So we're actually going to come back to this in a bit. But the main idea is that like, this is going to run a couple tests. You can actually leave it to run for a bit. It's going to keep on like, what do you call it? Passing this, it's going to try to connect to AWS, and it's going to take those details. It's then going to run that, regarding like connecting to AWS. So let me actually move back to the slides. Then we'll come back to that once it's pretty much done. I'm basically then going to cover up on like how to make great tests with Terratest. So this talk is actually take quite a while to run, because spinning up infrastructure takes quite a while to run. But then you can always find great ways to actually do things outside of that. So the main idea behind writing tests is that most people basically avoid them, right? You don't need to test anything if there's no quality inside, and that's basically the truth. If you are scared to test your code, if you are scared to test your infrastructure code, or you are scared to actually run it, there's some infrastructure that they have glue tape on it, like there's that one service that's been running since like 1990s, and they've never touched it. They're like, if you press just that one button, it doesn't come on anymore. So then you go online, and then someone actually tries to actually change something, then everybody gets fired, and it doesn't work anymore. So that's the difference, right? To actually start testing, you need to actually break it down and start small in units. So if I actually go back to the main example that we had in the code in this case, right? You basically have to then see that what do you call it? Most of all these tests are like unit tests. Like now, this Packer one is a unit test. And as you currently see right now, you see that, wow, it actually failed. And the reason for this is because of what? No valid credentials. This was actually intentional. And this was just to showcase like how some things work. So you could actually have built it up, but the main idea is that you do not want to be testing infrastructure randomly that way. So what I'll do right now is to go back and unset it. So from there, you unset your AWS access keys. You unset everything. Then you actually now try it again. So in this case right now, when I actually then try to run it now with the correct credentials, and we see something different. Wait. Let me switch over to the actual terminal. Yes, here. So right now, I'm going to run the tests using go tests -run that will specify the name of the test that we want to run. In this case, this test is called test Packer artifact. So we basically run test Packer artifact, and then we basically run this. So what this is going to do is that it's going to basically start off. It's going to pick up on the Packer template, and you notice that now it's pre-validating some stuff about the VPC. It's creating the Packer image, it's found the image, it's creating the temporary key pair. And then all of this is basically us just trying to build it. So this is basically Packer doing its work. The main idea behind it is that once Packer runs, Terratest then checks whether the output is the same as what we're looking to see. And how do we verify that? So in this case right now, I've already written here that whenever I finish building an image, right, this is the builder.json file. This is this file that we opened up a while ago, which is right here. So this is the builder. Let me actually switch. So this is the builder.json file. the one that we have. And this is our test. And this is our test, Packer Builder. So what we're basically doing is that we want to be able to run this and also then have it here. So we basically pass this into Packer. This Packer object is from here. We basically got it from the Terratest module that runs Packer. Then we then use this to then, what do you call it? We then run this. We then run this template using the build artifact function. We check whether it matches some string called AMI, because in this case right now, when you actually build it, you're going to get something called AMI dash a random string. So we check whether that's actually true. And if it is, then we actually say, okay, fine, yes, that's actually correct. In some cases, you could extend the test to actually go further into doing things like, okay, fine, let's actually see maybe, what do you call it? The AMI is in this particular region. Let's actually see whether, what do you call it? This AMI, like if I were to actually create an instance with it and exec and then check whether it's running, whether it actually goes. We could actually always do that and verify that all of that works exactly the same way. So now if I were to switch over to our demo, because what do you call it? If I switch over to our demo to showcase the tests, then what you'd notice is that right now we've created, like you see the AMI, right? It's basically like AMI dash some random string, right? And this is basically the value that we're actually going to be using to test. But the good part about Terratest is that after it builds everything up, it then destroys it. That's where that line that was actually doing the defer, that's where it actually comes in. Let me change to the slides back again and showcase what that's like. So like in the previous example, like we're just testing only Packer, right? There were other tests for things like Docker. There were other tests for things like the AWS instance, all those other things. The main idea is that when you're actually testing, your modules should be your starting point. So the reason why I created everything in modules is because modules are easier to test. Like the same way you have like, what do you call it, variables, functions, those ones are like first-class citizens when you're writing code. Resources are like that, right? So they're the ones that actually do everything, yes? So you can't really test them if you keep duplicating them multiple times, because it becomes harder to be able to find out, if I change this guy, do I need to change that guy? And then your test begins to fail because there's actually no consistency with the way you're actually writing Terraform code to start with. Again, there's no substitute for writing bad infrastructure code. So it's always best to start writing your Terraform code as modules. Then after you write it as modules, then you can then start testing, because it's only then that you actually then have the proper structure to keep testing. And then, if you choose to write a 200-line script, then you might just actually have to write it to unit tests too. And unit tests should cover like small parts of your infrastructure. Like you shouldn't be covering everything. You shouldn't have to, what do you call it, take up the entire bulk of everything. Like you can run your unit tests, you can run your integration tests, you can then run your end-to-end tests. Your end-to-end tests are the ones that would run. That one is actually in another folder, but that one takes a lot of time to run. So if you run your unit test first, then you have a much easier time writing your end-to-end test, because if every single stage that can run independently builds successfully, then putting them together, they should work properly. Any issues that you then have after that, those ones become a lot more minimal, rather than having to deal with 5. If one fails together, then you just fix that one. You should also randomize configurations when testing, because you don't want to hard code things. You don't want to have like your production environment variables always staying somewhere and then you go test staging and it doesn't work. So you should always make sure that you change those variables. Make sure that they're not static, ensure that you always have configurations that you can basically specify as you move along different environments. Also, make sure to always separate environments. You can't run your staging on prod. You can't run your test on staging. It's basically like moving around, driving a driverless car. You never really know whether you're in control or whether the car is actually taking you on the ride. The same thing with the environment, right? There are various times when you'll be running in the staging environment and you might actually overwrite something that is running. So it's always best that when you're writing your tests, even if they're end-to-end tests, because that one has to spin up every single part of your infrastructure, that you take it out, then you run it on a different environment. So, and also, there's also a part called state locking. So state locking is a thing where like you move your state and you store it somewhere else. Like, so if you run a Terraform plan, it's going to output like some JSON that tells you like what your current setup is like. You should actually take that out and not have it in there. Else you might, be reusing configurations like, that prod example. And if you're lucky, you might go from unemployed to customer, cover all these things. It's always good to test. And the last part that I would say is that you should actually drag most of your application and third-party integration tests to your infrastructure test, because there are various things that require you to actually set it up. So you should always have these things running beforehand. It's not just enough to set up your entire infrastructure, also set up your applications too, and make sure that as you test them, as you go along that testing pyramid cycle, once you get to the integration or end-to-end test stage, you actually then bring in all these things to make sure that, okay, fine, the way you are configuring your infrastructure is actually the proper way to set it up, those kind of things. And to just kind of round up, they don't really, tests don't really catch all your errors, but they kind of make most of the bugs go away. So the more you actually keep testing, then the less errors you might actually encounter while actually running your environments. And just to finalize, since there's still some time left, we can actually go back to where we have our code running. Yes. And then we would actually go down and we'll see that, yeah, so the test passed fine. Like we had everything running. We basically ran the Terratest part, and then we got, all the environments good. So I'm actually going to showcase another one where we're actually now testing with Docker. Let me switch over to the IDE so that I can show that. So in this case right now, we have this IDE and what do you call it? We need to reset a couple of things. So I'm going to come here and I'm going to create a new one. I'm going to set a couple environment variables, the things that we actually need to run it. So basically like a profile of like, this is just my account on AWS. And then I'll basically just set so I'll set the environment and pretty much that's about it. I don't need to set anything more to run this. And then when I'm actually here, so I have this test also for Docker, which is something most people don't really test, right? So the main idea for this is when you're actually testing, you should test from the units, right? The individual parts that actually make your application work. So in this case right now, I'm testing Docker because I have this main.go application. Very, very simple. It just returns hello world spelled backwards because why not? Say you have the hello in your application. It's pretty weird, but it's kind of good. So right now, like the same way that we do the unit test, we then come on here and then we can actually then run this and just see whether this actually goes. So if we want to go run tests, then we actually go test run, and then we actually then see this go through. So what this does is it basically just checks whether like our build can run fine and whether, we can actually access a port on the application as running. So I check whether the return code is 200, and then I check whether the response is the same. So right now, if I run this, right, you see that at the moment, oh, this is actually running for Packer. So I actually want to run this for Docker. So I'm going to copy this again, and I'm going to change it here. What this is going to do is that it's basically just going to start off, it's going to build the image, then it's going to test it. So what this did was it just checked whether it's just sets some build flags, set some other things like environment variables for like the ports, and then it basically just checks whether like, okay, fine, can we actually access this application and do we actually get the same response as what we actually have here? So this enables you to like keep on testing your applications until when you can get to an end-to-end test stage where you now put it all together. It's Packer with the Terraform code, and then you actually then check whether like you can access the same application. And at the moment, you just see that after you do all of this, you pretty much have your end-to-end testing framework of that. So to just quickly finalize, I'm just going to run through this and say, you know, once you've actually had a great time updating your tests, you can pretty much continue doing that. Thank you.